Let's talk about a time series graph. A time series graph represents data that occurs over a specific period of time. Some suggestions for drawing a time series graph. We'll start by drawing and labeling our axes. And this is by hand. If we're going to do this by hand, this is how we would go about it. X-axis is our time variable. We'll plot each point for the values in the table, and then we'll connect the points with a straight line, not a curve. Must be a straight line. Now, if the data is complicated or has a lot of decimal points, like our data here in the next example, it might be difficult to do it by hand. So let's see how to do it using technology. So in our example, we have something called a PCI, a Partisan Conflict Index, that tracks the degree of political disagreement among U.S. politicians in the federal government. It's found by measuring frequency of newspaper articles reporting disagreement in a given month. Higher values of the index suggest greater conflict among political parties, Congress, and the president. The data in the table represents the PCI in February from 2000 to 2019, and we'll construct a time series plot and answer some questions. So let's use technology, create a time series plot. I have my data in Excel, and it is selected, so I'll go to Insert, and a time series is just a line chart. So I'm going to insert a line, and we can see we've got this weird situation again with two lines. It's because it's taking the data in our column A, which is our years, and plotting them down, but we don't want that. Let's clean up our table a little bit. We want to select our data, edit the horizontal axis labels to be the years. Makes it kind of nice because it turns them on their sides. And then we need some axis titles. And instead of calling this PCI, because what does that mean? Partisan Conflict Index. I do want to make an indication on my chart that this is in February of every year, so I stuck February down in with the years. And we can see that the time series graph, it bounces around a little bit, but then it's got some increasing throughout the 2000s until we reach 2016, 2017. So the highest value in our PCI is in 2017 at 241.48, which is almost 3 times what it was in 2000, which is pretty significant. So why was that the highest? What happened in 2017? Well, in 2017, President Trump was inaugurated as president. There was a lot of partisan conflict. It had been steadily building, notice that, steadily building until that point. There was also the Women's March for the first time in DC and across the nation. And there were also some pretty divisive policies, particularly the travel ban that was initiated right after the president took office. So a lot of reasons, a lot of examples in the media of a lot of different conflicts. Creating the same graph in Google, we can go through the similar steps. We have our data, insert, chart, gives us a nice line chart with the same shape as expected. Now how about a pie graph? A pie graph is a circle divided into sections according to percentage or frequency in each category. We do have to be careful using pie graphs because they can be misleading, and they should really only be used when we're talking about a whole of something. Alright, so one thing I need you to do, cross out this line right here from the previous lab assignment. This was from an old lab assignment that I used to do with my class, I didn't do it for this time around, so we can cross it out. We're going to use technology to create a pie graph on this snack data. So here we have potato chips, tortilla chips, pretzels, popcorn, snack nuts, a total of 30 pounds, and we need to create a percentage of the total here in order to talk about a pie chart. Usually pie charts represent percentages. They don't always have to. We could create it on our actual data. It is pretty easy to create the percentages from this. This is a relative frequency categorical distribution in a way. We are talking about relative to the whole. But let's see how to do it in technology. To create a true pie graph by hand, we need to have some knowledge of angles and trigonometry, and as mentioned before, that's just too much. Let's use Google first this time. In order to get our percentage of total, we're going to take the pounds divided by our total, and we're going to lock this cell reference up here. So B7, we're going to put some dollar signs around the B, $B, $7, so that it locks our cell reference and we can drag down and get our percentages right away. Changing the format to percent, we can create those percentages very quickly. To create a pie chart, we don't need the total in there. We'll click Insert and Chart. It gives us a bar chart at first. We don't want a bar chart. Change this column chart to a pie chart right next to it. And make it a little bit smaller. The title should be Snacks. And it automatically creates these percentages. I only selected the first two columns, but you can see that it did nicely and accurately reflect those percentages here on the sides. The other thing that you can do with a pie chart, on the slice label, you can give it both a value and a percentage, or you can say none. Don't ever do a donut hole. They're misleading. Don't do them. Leave it as a pie chart. I don't want to label my slice. So right now I'm just trying to look to see if I can change the labels themselves. And we have a text label that's auto. That doesn't look like that I can change it very much, other than going to the pie chart and on the slice label, I can change it to value and percentage so that it reflects that column for the pounds. It does not show up on the smaller values, unfortunately, but it will show up on the bigger ones. Let's take this over to Excel and see how we would do it in Excel. Same idea for the total. B2 divided by B7. Lock the cell reference with dollar signs around it. Take the handle, grab it down, and then we'll go home, find that percentage format. We do get a different rounding, but if we wanted to increase the decimal, we could. And then for our pie chart, we'll select our data, insert pie charts right underneath our line chart, insert pie chart, 2D pie, never choose a 3D pie, and never choose a donut. The reason I say this is that three-dimensional pies like this are extremely misleading. I will leave it on here for a second and we're going to go change it. Notice here we have pretzels, popcorn, and snack nuts. Down here with the snack nuts, it's at 8%, but because of the perspective, it does not look like it's nearly half the size of the pretzels at 14%. That's what I mean by misleading. It's extremely misleading when you start looking at this. Also, the tortilla chips look incredibly large because they're right up front with you. And the potato chips are actually larger, but because they're going back into the page, they don't look as big. So we do not like these three-dimensional pie charts in statistics. We need to change this. So let's come back up here, make it a 2D pie, nice and flat, easy to see that our potato chips are much larger than our tortilla chips. And now the proportions for the snack nuts and the pretzels make a lot more sense. We can do some labeling here. I selected my data and I'm right-clicking. I can add data labels, and we can actually format these labels in a bunch of different ways. If we click on them, and you can see that they're all selected, we get the Format Data Label menu. I'm going to click over to the bars and go to Label Options. We can give it a category name. We can give it a percentage. We can put it on the outside or in the center. That gets a little crowded. Inside end just means it's like right on the edge. I personally like the outside end. It seems like it showcases the values and it's easy to read. Then we'll change our pounds to snacks. If you wanted to delete the legend, you could. Makes things a little bit bigger in the long run. And there we have our pie chart. We have 2 more types of graphs left in this section, and these we will do by hand.